Algebra 1, Lesson 30, Algebraic Phrases and Decimal Parts of a Number. So, algebraic phrases can be a little bit difficult, and I'm going to actually recommend you tab Lesson 30 in your book, because you may need to flip back to this example page as you run into your problems that have to deal with algebraic phrases, because this will help you decipher what you're trying to do. We should have spent a pretty good amount of time on this in class, but we'll go straight to the practice. But if you haven't yet, go ahead and put a tab on Lesson 30 so you can reference this guide here when it comes to solving your problems. And we'll go into the practice. So in A, they tell us that 5 times a number, 5 times the sum of 3 times a number and negative 5. So we have to do 5 times a sum. So sum, as we know, is the answer to an addition problem, so that sum is going to have to be in parentheses. So at our problem, we're going to have 5 times a sum. So we're going to have parentheses, and in that parentheses we're going to be adding multiple numbers. So we have 5 times a sum of 3 times a number and 5. So the two numbers we're adding are 3 times a number and 5. We write 3 times a number as 3x or 3n because we don't know what that number is. So the first one we're going to put as 3n or x, any kind of letter we want to use to represent the number we don't know, and negative 5. So we could put 3n plus negative 5, or we could change this plus sign to a minus and make it 3n minus 5, which means our final answer would be 5 times parentheses 3n minus 5. Let me double check in the book, because we could simplify that a little bit more if we wanted to. And no, that's as far as they want us to go. So for our final answer, we're just going to have 5 times parentheses 3n minus 5. And that's A. Now for B. They tell us the product of 3 and the sum of a number and negative 50. So we have to multiply 3 times a sum. So the product of 3 and the sum is going to be a number and negative 50. So the sum is going to be a number, which we're going to represent as x, and negative 50. So we can represent that whole idea as our sum, and then we have to do the product of our sum and 3. So then 3 times the sum, and that's how we would write that one. Moving on to C. We have to do the sum of 5 times a number and negative 13. So we have to add 5 times a number, negative 13. So since we're going to do sum, the first number that we're going to add up is going to be 5 times our unknown number, which we'll draw as x this time, and then it's being added to negative 13, or we can just put 5x minus 13, and that's what C is going to be. You guys will get better at doing these as you go along throughout the school year, so we're going to constantly build on this skill of turning these words into algebraic expressions. D, we have 3 times the sum of the opposite of number, negative 7. So this one's really big. We'll just take it piece by piece. First, we have 3 times the sum. So 3 is going to be multiplied by a parenthesis. So we'll put 3 outside a set of parentheses. And then we've got the sum of what? The sum of the opposite of a number and negative 7. So if we write an unknown number as x, the opposite of that would be negative x. And then we're adding that to negative 7, or we can just put minus 7. And that's our sum. And then we're done. Moving on to the next problems, we have to find decimal parts of a number. So if you remember our equation, fraction times of equals is, we're going to take that same equation and we're going to use it with decimals. So the equation that you're going to have to learn now is decimal times of equals is, which is the exact same format as fraction times of equals is. They both use the same format, so the only thing you have to remember is that this equation can be used for fractions or decimals. So let's go to our problem. In E, they say 0.16 of what number is 10.24. So 0.16 is our decimal, of is our unknown, and is 10.24. So we'll fill that in. Our decimal, 0.16, times our of number, which is unknown, so that's going to be x, and is, or equals the is number of 10.24. Now, if you remember how we did our equations of solving with decimal numbers, we can multiply this entire thing by 100. That turns it into 16x equals 1024. Then we divide each side by 16, and that will give us our answer for x. From here, I know I can reduce each of these by 2. I don't know if I can reduce them by 4 or 16, but I know I can definitely reduce them by 2. So 16 divided by 2 is 8. 2 goes into 1024, 2 times, 512 times. Again, we have two even numbers, so we can reduce by 2 again. We get 4, and then 2 goes in 2, 5, 6 times. 256 over 4. We'll reduce by 2 one more time. Divide by 2, and we get 1, 2, 8. Okay. So we can reduce by 2 again. And we get 6 and 4. So our final answer is going to be 64. Again, these problems are just like the decimal problems. You start off with your equation, you fill in the blanks that you know, and then you solve for the unknown. And that's all there is to it.